Welcome to Eureka Math. I'm Mr. Shankel. I'm going to help you today with Module 3, Lesson 16. Let's get started. All right, we've been working with ordered pairs in the coordinate plane, and we've got a couple of example problems today I'll work through with you. Number one says, how are the ordered pairs 4, 9, and 4, -9 similar, and how are they different? So let's start with that. How are they similar and how are they different? Well, you can see that the first number starts with an x value of 4, and the second ordered pair also has an x value of 4. So that's a similarity. In both cases, if we were to plot these points, we would move 4 places to the right. So from the origin, I would move 4 places to the right. And then we do have some differences. The y values, the second number in the ordered pair. One second, let me get a new. Here we go. Highlighter. Okay. The second numbers right here are different. First one's a +9, second one is a -9. So from our +4, which we moved this direction 4 places to the right, the first 9 here will tell us to go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would go to right here, and there's 1 point. And then the second one will tell us to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here. So we see that we do have 2 different points. One that is above the x-axis and one that is below the x-axis. So there's some differences and similarities. The second question, are the 2 points related by a reflection over an axis in the coordinate plane? And that answer is, well, maybe they are. So let's take a look. If we went from, wrong tool, here we go. If we went from this +9 and went all the way down to the x-axis, that has a distance of 9. And then similarly, if we did the same thing, we would, let's get here, we would do the same thing down here. We could see that we also have a distance that is equal to 9. Notice that they're both 4 spaces away from the y-axis. That's right here. So they're both 4 spaces away from the y-axis. And then from the x-axis, one is 9 above and one is 9 below. So in this way, we can see that they are reflected over the x-axis. So the axis of symmetry is this x-axis. Let me get that here. The x-axis right here is our axis of symmetry. We have points above, 9 spaces above, and a point 9 spaces below, and they're both the exact same 4 spaces to the right of the y-axis. So that is a reflection, and so the line of symmetry is x. Okay, let's try number 2. Given the point -5, 2, write the coordinates of a point that is related by a reflection over the x and y axis. Okay, so if we start with that point, let me get us a coordinate plane here that we can work with. Okay. Pretty good. Negative 5, 2. Where's that going to be? Well, it's going to be left 5 and then up 2. So right there is our point. Okay, and then we are to write the new coordinates of a point that is related by a reflection over the x or the y. We'll do both. Here is a reflection over the x-axis. Here's the x-axis. So that is our line of reflection. That means my new point is going to be the same distance from y and the same distance from x. So it's right here. Notice that we have 2 spaces here and 2 spaces here. A reflected point is always the same distance from the line of reflection as the original point. So our new point would be negative 5, negative 2. That would be an ordered pair that's related by reflection over the x-axis. If we wanted to reflect over the y-axis, we got to look at the y-axis right here. We have to be 1, 2, 3, 4, 5 spaces to the right. So right here. And now this point and our new point are reflected over the y-axis because they're exactly the same distance away. This one's 5, this one's also 5. So our new point is the point positive 2, sorry, wrong, positive 5, positive 2. The point 5, 2 is reflected over the y-axis. Okay, I hope that helps. I'll see you again next time.